Business and financial math students. In this video, I'm going to explain how to work through applied activity to time value of money. This applied activity is worth 15% of your grade. When you open the file, you should see the title page. Please make sure you add both your name and your student number here. Also, please make sure you do not adjust the values here that will be used to automatically calculate your grade for the assignment once I enter your individual marks for each question. Just like your last applied activity, this applied activity will be structured so that I'll teach you how to perform calculations related to the time value of money within Excel, and then you'll work on applied activity part 1 and part 2 individually that will be related to using the functions that I teach you in the lesson. So Microsoft Excel is essentially an alternative when dealing with compound interest to using your financial calculator. For all the types of problems we have solved related to using the financial calculator, you can solve these problems within Excel instead. So, as a quick example, here's the lesson note that we worked through in lesson 4.1 on compound interest. We're going to do all of these types of problems again, but instead of using the financial calculator, we're going to use the Excel functions to perform these calculations instead. Last semester in your Excel course, you learned how to use a variety of functions. So we'll just keep expanding your knowledge of functions in Excel today to teach you some new ones that are specifically related to compound interest. So Excel does have unique functions for everything you want to calculate. So we're going to do an example of calculating future value, calculating present value, calculating N for number of compounding periods, and calculating interest rates. For all of these things that you can calculate, there is a different function in Excel, but luckily, most of the time, the function corresponds to the same name that the buttons on your financial calculator have, so it makes it easier to remember. Let's start by looking at an example. So let's say you invested $5,000 for 10 years at 9% compounded quarterly. How much money would you have? You still need to be able to extract the information from the question in the same way that you would if you were using your financial calculator. When using the financial calculator, if you want to find the number of compounding periods the money's invested for, it would be 10 years times CY. The formula is always years times CY, where CY would be 4 because we are compounding quarterly. So I'll fill in that CY value as well. For IY, the interest rate, the question says it's 9%. So I'd fill that in too. We always will use this value of 0 for the payment when we're dealing with basic compound interest problems in this learning outcome. And because we want to figure out how much money we'll have in the future, that means we're starting with 5,000 in the present. Present values we enter with a negative. Just like on the calculator, Excel follows the same rules that present values also need to be entered as a negative to get the correct answer for the future value. Then for the future value, a formula exists to calculate this for you. Instead of on the calculator where you have to compute FV, in Excel you use a function, and that function is called FV. It keeps it nice and simple. The small difference between using Excel and using the financial calculator is on the financial calculator, you have to enter all of these things separately. N, IY, CY in that external menu, payment as 0, and your PV, whatever it is for the question. In Excel, instead of accepting both IY and CY, it takes one thing, the rate. That rate corresponds to little I, which is the formula for interest that would have been used when you use the formula method for solving compound interest problems. So when we looked at the formula method in lesson 4.1, we had this little I, that was your interest rate from the question divided by the compounding periods. That is the one that Excel also takes. So you have to take your interest and divide it by the CY to get the first argument, the rate. Then the second thing is the number of periods. That's just your N. The third thing you have to put in is your payment. That will be 0 for all of the questions you do in this activity. And finally, the PV, which just click on that, but it does have to be negative to get you the right answer for FV. We don't have to put anything in for the type right now. That will be something we learn about in the future of the course. If you press enter, you should get 12,175.94. If we go back to the lesson where we did the same question on the financial calculator, it's the same number. So Excel is doing the same thing as the financial calculator. It just uses a function in Excel instead. Let's say we look at a slightly different question. This one says, find the principal, that's the present value, that will amount in 6 years to $17,715.61 at 10% compounded semi-annually. Again, you'd have to find the value of n. 6 years at semi-annual compounding, which is 2, would give me 12 compounding periods. My interest rate is 10%, and semi-annual compounding would mean CY is 2. The payment is 0, and we're calculating the present value this time, which means that the $17,715.61 must be my future value. I enter that one as a positive because the present value is the one that always gets the negative. On your financial calculator, the button for present value is called PV, and in Excel, the function for present value is also called PV. It follows the exact same rules as for the future value formula, where you have to take your interest and divide it by CY, so that's the only part that's a little bit different than the calculator. You have to put in your N for number of periods, your payment, and your FV. Right now it's kind of covered up, but it should be B26 that you put into the cell reference for your FV, and that's all you need to enter into this function. We don't need to enter a type yet. And this should give you $9,864.71 as your starting point for PV. That's the same number we got using the financial calculator for this exact same question. So it's just an alternate way. Again, if you want to calculate FV, you use the FV formula. If you want to calculate PV, you use the PV formula. In the next question, we're going to look at calculating N. That's why I've got the N value shaded in. If you look inside of either the V or PV formulas, notice that when we entered N, it was not called N, they call it N per, which means the number of periods. That's just to distinguish time in years from the number of compounding periods, which is the years times CY. So because it was called N per inside the function, that's actually going to be the name of the function used to calculate N as well. In order to use that function to calculate N, we'll look at the problem that Jennings Holdings invested $43,000 at 6.65% compounded quarterly. A report from the finance department shows the investment is currently valued at $67,113.46. How long has the money been invested in years? So if I put what I do know from the question, I know the interest rate is 6.65% with quarterly compounding. If you ever see that it rounds it for you, just increase the number of decimal places so that you can actually see all the decimal places for your interest rate instead of it being rounded. You can use this button for formatting to see all the decimals. The payment is still 0. What can be tricky about questions where you have to calculate N is you'll have both an FV and a PV, so you'll have 2 amounts of money and you have to know which one is which. The PV should always be the smaller amount because money grows over time. So the PV would be the 43,000 and we have to enter that as a negative number, whereas the FV would be the larger amount. So PV is smaller, FV is larger, PV also gets the negative. Once you have all of those numbers from the question, that's where you can use this new function called N per. Again, this is slightly different than the calculator method where the name is just N. Here we call it N per for number of compounding periods. For the rate, you still have to take your IY and divide by CY. Payment is still 0, which you could type in, or I'm just always going to reference my 0 cell. I'll put in my PV and I'll put in my FV. We don't need to use a type at this point in the course, so you'll always be able to leave that one blank, close the bracket, and press enter. And we get about 26.99999 compounding periods. That's essentially almost 27 compounding periods. But because we're compounding quarterly in this question, this technically means the number of quarters. And if you tell someone that they need to invest their money for 27 quarters, they might not have an intuitive idea of how long that is. So for that reason, we'll convert it back into years. Remember the formula for N is years times CY. So if I want to solve for years, I'll do the opposite of timesing by CY, and I need to divide by CY. So I would take my answer for N and divide it by CY, and that converts it into a number of years. So if I tell someone how long they need to invest their money in years, 27 quarters works out to 6.75 years. Another way of saying that is 6 full years and 3 quarters more. And that's it for this question. We use the n per function to be able to calculate the number of years that the person invested their money. Please note that the n per function, the answer you get from that, will always match with cy. What I mean by that is because the cy for this question was quarterly, this is a number of quarters. But if cy was 12 for monthly, then this answer would be a number of months. If cy was 2 for semi-annually, then this answer would be a number of semi-annums or half years. If CY was 365 for daily, then this would be a number of days. So it does depend on the CY, and that's why Excel calls it N per. If you want to convert it to years or some other length of time, you have to actually use a conversion formula to do that. And finally, the only type of question we have not looked at that we learned on the financial calculator is solving for the interest rate. So that's what this last question looks at. An amount of $4,100 earns $725 interest in 4 years and 2 months. It asks for the nominal rate of interest that's compounded quarterly, the effective rate of interest, and an equivalent rate of interest compounded monthly. We did this question in lesson 4.1 as well. If you scroll all the way down to the bottom, it was where we learned to use that external function or second function in your calculator that's used for interest rate conversion. It was called the iConv menu, where you can solve for the interest rate first, and then you can convert it to an interest rate compounded at another frequency. So we're going to do the same thing now, but in Excel. I actually find it a little bit easier to do in Excel than using the financial calculator. So first step, before we can find IY, we need to fill in what we do know from the question. So the amount of time here is a little bit trickier to find because it is a fractional amount. We have 4 full years plus 2 months more. I take the 2 over 12 to convert that into years, so I have a total number of years, and then the formula for n is always years times cy. So the first part of the question says they want us to find the interest compounded quarterly, so the cy would be 4 for 4 quarters in the year. So I'll fill in that cy value while I have that topic of discussion, that the interest is compounded quarterly. And again, if you need to see the formula for n, it's 4 full years plus 2 years over 12 months to convert that into a number of years. 2 months over 12 months, sorry, and then multiplied by 4 to get the number of compounding periods. The payment's always 0. Again, PV should always be the smaller amount, and FE should always be the bigger amount. This question, though, is written in a little bit of a different way. It says you start with $4,100. I put it as a negative because all PV should be negative. But the reason this one's written in a different way is it says that you earn $725 interest. That means on top of the $4,100 you started with. So if you want to find the future value for this question, you'd actually have to add the $4,100 you started with plus the amount of interest earned. It's just worded in a slightly different way, but when you actually do the computation, then you'll get the future value that is bigger than that present value you started with. Once we have all these filled in, we can calculate the one unknown, IY. If you again look at all the other formulas that we've used, the first thing you always entered was the rate. That's the interest rate. And that is actually what the name of the function is when you want to calculate IY. It is your rate. So again, you have to put in number of periods, payment, present value, future value. Once you've put all of those in, what you have to be careful of is this technically will always give you your little I value. Just like we talked about earlier, when I go into the functions, I have to always take my IY divided by CY to put in the rate in Excel. So this is technically giving you little I, not IY. Remember, the difference is that little I is IY divided by CY. So just remember, Excel always works with little I, just like the formula versions do rather than the financial calculator. So if we want the version that the financial calculator gives you IY, we have to do the opposite of dividing by CY. The opposite of dividing by CY is to multiply by CY. That's the only change you need to make is if you multiply it by your CY, that is then the IY value that matches up with what we found on the financial calculator. 3.926921 when you round it. I just have one more decimal place in Excel. Then the next part of this question, once you have your IY, is that we found the equivalent rate of interest compounded monthly. In order to take an interest rate that's compounded quarterly and convert it into an interest rate that's compounded monthly, there's two steps in the process. The first is that you find the effective rate. The effective rate means the interest rate converted to compounding in 1 year. So basically, the effective rate converts it to just a 1 year compounding amount. And then once you have the 1 year compounding amount, you can convert that into other compounding amounts. So the formula for finding the effective rate in Excel is effect. Then you put in the answer you found and how frequently that compounding period was for the one you found. So for IY, the compounding frequency was 4 times a year. So you put in that you compound 4 times in a year, and that will give you your effective rate. If you see the number signs like I do, it just means that there were too many decimal places to fit in the cell, so you just need to drag out your cell to make it a bit wider. Once you find the effective rate using this formula, then you can convert to a nominal rate. The formula for the nominal rate is nominal. Forgot an N. There we go. And it again takes two things. Number one, the effective rate, and then the number of periods that you want your interest rate to be compounded at. The question says we want an equivalent rate compounded monthly. So we put in 12 because we want an interest rate compounded monthly. Once you do that, that's your final answer for the monthly compounded interest rate. So there's always two steps. We found the interest rate first. That was compounded quarterly because that's what the question asked for. Then if you want to convert it to an interest rate compounded monthly, first you have to find the effective rate. It's kind of like a stopping point in between where it goes down to 1 year rate. And then from that 1 year rate, you can convert it to a nominal rate that's compounded monthly, which is the final equivalent rate the question asks for. Okay, so we've now learned all of the compound interest functions in Excel. IY, which is the rate formula, N, which is the N per formula, PV, which is the PV formula, and FV, which is the FV formula. The only additional thing that we did in class that we haven't done here is questions where you have to combine multiple calculations. So let's look at one of those as our last example in this lesson today. So we did lots of questions on equivalent values in our lesson note. This question is an equivalent value problem because it says payments of 400, 500, and 600 are due in 8 months, 12 months, and 16 months from now. What is the single equivalent payment due 2.5 years from now if interest is 0.85% per annum compounded monthly? So we did this question in class, but I want to show you how you can do it in Excel. In class, we drew out the timeline by hand, but in Excel, I actually built this timeline just using text and borders. So what I mean by that is this, for example, right here is actually a border. So if I say no border versus if I put on a bottom border, and here if I put on a right border, I can make the little kind of tick marks just like we did in on paper rather than digitally. To save some time in the video, I didn't do all of the little borders live in front of you. I put some of the basics in here so then I could build parts of it together with you. So I made the little borders and put in the times that are given in the question. In 8 months, you have $400. So as part of what you're required to put in your 5-point check, you'd have to put in the amounts of money. In 12 months, you have $500, and in 16 months, you have $600. So that's one thing you need for your 5-point check is the times and the amounts of money. So that would get you 2 marks. Another thing you need in your 5-point check is the interest rate. So I take that from the question, 0.85%, and the compounding frequency, compounded monthly. So that would be 3 marks. Another thing you need is amounts of time. and your arrows for if you're finding future values or present values. In this case, if we want to find the accumulated values all at 2.5 years from now, that's more into the future. So I would actually have to calculate 1, 2, 3 FVs because I'm moving forward in time. And for those FVs, I'll calculate the Ns as well. Remember, the N only corresponds to the length of the arrow. So if you're going from 16 months to 30 months, that difference would be 14 months. I'll leave it in months because the CY is 12 for compounding monthly, just like we did in class. For the second N, it's from 30 to 12. So 30 minus 12 is 18. And for the last one, it's from 8 to 30. So 30 minus 8 is 22 months. That would be everything you need for 5 marks on a timeline. So you have to have amounts of money. You have to have the times that those money are paid. That's 2 marks. IY and CY gets you to 3 marks. The arrows for the FVs get you to 4 marks. And these amounts of time N get you to 5 marks. Now we need to use Excel to calculate the FVs instead of using the financial calculator. So it doesn't really matter which one you do first, just try to stay consistent with your naming. So if I said FV1 went with the $600, for that one, N is 14. The interest rate is 0.85 for all of them. The compounding was 12 for monthly compounding for all of them. The payment's always 0. And like I said, if we're starting with the $600 as FV1, negative 600 would be the PV. Then, if I want to find the future value, I just put everything in to my function. That the rate I have to divide in Excel, that's my N, my payment, my present value. And there we go. That's now the future value calculation. Then I go on to the next one. FV2 I said was the one that went with the $500. The IY for that stays the same, CY stays the same, payment stays the same. The present value changes to only $500. And my formula for the future value, I get a lot of practice using because I have to find it again, where first I divide the interest rate, then my number of payment periods, size of the payment, which is 0, and present value, which is the negative 500. So I get 506.41. And then finally, for the last one that I haven't done yet, the N was 22. The interest rate doesn't change. This time for the present value, I'm starting with negative $400. And then again, I'm using my FV formula, where I have to divide the rate out, number of payments, size of payment, present value amount, and there is my future value. Because the 400, 600, and 500 were all scheduled payments that will be replaced by one single payment, the final step to solve for X is just to add together all the numbers that you originally found for FV, because the 1X will replace all 3 of these amounts. So I will add them all up, press enter, and I get my final answer. This is the same final answer as when we did this question in class. I just wanted to show you how we could make this timeline in Excel and also calculate the FVs all in Excel instead of doing it by hand. So in this lesson today, we looked at all the individual formulas for finding FV, PV, N, and IY. Then we looked at how you can solve an equivalent value problem in Excel. Now, once we've done this lesson, I just want to give you a couple pointers on what you're going to have to work through on your own. So for activity part 1, I'm going to give you 2 different questions. So 2 different questions that you have to solve. I do give you some hints on like what you have to find with the boxes that you have to fill in, but as part of these questions, you will have to make a timeline. A couple things I wanted to point out is you can make the timeline fully in Excel. What I mean by that is just like I did here, you could do a similar timeline. If I wanted to make my own timeline version, I would start by copying my work from this example and paste it in here. Then I would start to alter it for this question. So for example, the interest rate for this one says 4.5%. The compounding is monthly. This one says you have 3 years and then 1.5 more years that it's changed. So you'd have to switch the amounts, like maybe from today to 3 years, Then you'd have to put like more time into the future and put the amount of time you need. But the good thing about copying my timeline is it saves you some work with having to worry about the borders and things like that. You can then update it for your own purposes. So that's one way to do it, is just make the timeline directly in Excel. Start by copying from mine and then update it to include the amounts of time you need to from the question. For the arrow part, again, you can just copy the arrows from the last question and you can move them around. You can resize them. When you resize them, you might have to just make them look straight again, but you can copy and paste anything you need to for what you're calculating so that you'll be able to make it look similar to the ones I did completely in Excel. If you don't like that method and you'd prefer to still create a timeline by hand, you can, number one, if you have a tablet or something like that, you can draw in Excel. So if you have a tablet where you can draw neatly, feel free to actually draw out your timelines in Excel. I'm using my mouse right now, so obviously I cannot be that neat. But if you have that tablet, you can draw directly in Excel. Finally, a last option is you can draw it on paper by hand. Once you've drawn it on paper by hand, you can take a picture. And then remember in your Excel class, we learned that you can insert pictures into Excel using this button. So take a picture, you can upload that picture and paste it in here using that insert button if you'd prefer. So I'm not picky on how you make the timeline. It could be in Excel, like mine was, just typing it in. It could be drawn in Excel if you can draw neatly, or you can insert the picture. You'll do that to solve both of these problems. This one is one where you have a change in interest rate. So we did these types of questions in lesson 4.2. And the last one is just another equivalent value question where you have to solve for an unknown payment. That one, again, is similar to this example where it's an equivalent values problem, no changes in interest rate or anything like that, just the single interest rate. So these ones, I give you the question, you just have to solve them, showing me you know how to use the values in Excel. The question that's a bit different is question number 2. So question number 2 will require a lot more creativity and critical thinking. So in this one, you are going to pick a vehicle you'd like to purchase, a car, a truck, a snowmobile, a quad, anything you would like. And on most dealership websites, they do have information related to financing. So how much you would need to pay for the vehicle. So I can show you an example of that. Just going to pull open an example. So let's say I wanted to purchase a Toyota. So I have the Toyota website up. It's still loading right now, but let's say I have this Tacoma and I would like to make a purchase of it. It has all the leasing options up here, and no matter what type of vehicle you might be interested in, most websites have this information available in some way, even though it might look different. I would click the edit payment details, and instead of leasing it, you want to finance it to purchase it. Also, you can change the amount. So for example, if there's an option to include tax, please always include the tax because that will change the financing amounts. Once you've checked the box to include tax, you can also choose different payment frequencies. Bi-weekly and weekly, we have not really talked about those types of payment methods. So if those are options, I recommend choosing monthly. And then you also have an option for how long you want the payments to be. You can choose whatever you would choose in real life. Like if you want to choose a longer time frame, 60 months is 5 years, so I'll put that amount. And assume no down payment. So do not put any down payment. Then once you set it up how you would like, I need you to give me the link to the website where you got it from and take a screenshot of this information. So for me on my Windows, I use the snipping tool for screenshots where I can cut out a little screenshot of the financing information. If you have a Mac, you might be able to use preview to do that instead, but this is what I'll need you to put onto your assignment. So for example, here's the link to the Toyota website. I'd copy it in. Here is the amount of the payments based on the financing information. So you get marks just for putting these into your spreadsheet for whatever vehicle you want. It doesn't matter to me what you choose, just as long as you have the link and you have the financing information. Once you fill those two things in for your vehicle, you'll have to find the cost of borrowing. What the cost of borrowing is the payment amount that the website gives you times the total number of payments. So if I choose that I'll make monthly payments for 60 months, I would be making 60 payments. Then you would subtract the total price of the vehicle as it costed originally. That's how much you pay just because you couldn't buy the vehicle in cash today. So we call it the cost of borrowing. It means it's the cost of financing it instead of being able to buy it in cash. And there will be some cost of borrowing because there is interest. When you buy from a dealership a vehicle, usually they charge simple interest. So step one is figuring out under simple interest how much the cost of borrowing would be based on the payment information provided on the dealership website. Then you're going to do a kind of a made up theoretical situation that let's say you could get money from a family member as a loan instead of financing through the dealership. So the family member says you have to repay the cost of the vehicle. So for me, if I was looking here, it would be this one. $69,173.04. I'd have to repay that cost of the vehicle in 5 equal payments in 1, 2, 3, 4, and 5 years. Because I don't know the size of the payment, this is the type of question where you'll have 5 X's. We did some in class where we had 2 X's that you had to solve for. This one you'll have to have 5 different X's and solve for what that X value is. You'll have to use the same trick we learned in class. What I mean by that is remember in class we'd put in 1 for the future value because that's the coefficient in front of the X and solve for the PV. You'll use that same trick except now there'll be 5 X's instead of just 2. So here's where you can put your work to find the size of the payments if you borrow from a family member. And then just like you did before, you'll find the total cost of borrowing from the family member. Based on that cost of borrowing, you'll have to say which one's more expensive, borrowing from a family member or borrowing from a dealer. You'll put your explanations here. And then finally, the last part of the question says, if your family member agrees to charge you the exact same amount as the dealer, so no difference, what would be the interest rate they have to charge? Because in the previous part, I don't think I mentioned this, you use the exact same interest rate that the dealer promised. So here it would be 6.59%. But in the last part, the question says, if you want to owe the family member the exact same amount that you would have owed Toyota, what is the interest rate that would need to be used? So this one you'll have to calculate an IY, whereas the other questions you're calculating future values or present values for the activity questions. Okay, so that is the assessment. Once you are done, you have to upload this to Moodle by 11:59 p.m. On the due date. Make sure again you have your name and student ID on the first page. And that's it for your second applied activity in the course, worth 15%. I will still be available by email if you have any questions for me about the activity, so please don't hesitate to reach out. And thank you for watching this video.